Okay, so given this graph of position versus time for a simple harmonic oscillator, determine the period, that's the amplitude of it, right? Amplitude. And this thing here isn't in the data packet. This is our V, our maximum V, right? Our V max, okay? And it is, if we look at the formula packet, the maximum velocity is just omega times x naught. Okay, so we got to figure out what omega is, and then we'll figure out what x naught is. Okay, so let's do this. V naught is the maximum velocity is omega x naught. Okay, omega is 2 pi, over t. Well, let's look at this thing here. Okay, let's figure out what t is. We start at 0, and in 2 seconds, we're back where we started. So t is 2.0 seconds. Okay. Our amplitude is, well, it goes from +3 to -3. So our amplitude is 3 meters. Okay. And then our maximum velocity is just omega times x naught, right? So let's figure this out. Omega is 2 pi over t, so 2 pi over 2. Well, that's just pi. Omega is pi, so we can do this, right? Our maximum velocity is omega x naught, so that's just going to be pi, and then our x naught is 3, pi times 3. I think you're supposed to write it like that. Okay, so the maximum velocity is 3 pi, okay? Now let's take a look at this position graph here. Okay, an equation for its position. Well, this is pretty clearly a negative cosine curve, because cosine starts positive, if you recall, and does that, right? So this is a negative cosine curve. So x is negative something times the cosine of something. Okay, well, let's figure it out, right? What goes inside that thing is omega t, right? So, hello. That's going to be omega pi times t. That's easy, right? And then what goes in front is the amplitude, okay? So let's put the amplitude in front. The amplitude is 3.0 meters. There we go. So now we're set, right? We've got something that has an amplitude of 3 meters. It starts as it's a negative cosine. It's got the right omega. I'm going to say that that's a winner. And you could graph that on your calculator, by the way, okay? Okay, now let's write an equation for its velocity. This is going to be trickier, okay? And I purposely picked something that's just not in the data packet because they could give it to you. They're not, they don't always give you stuff that's a slow pitch in the strike zone here, okay? So we need to figure out what the velocity is. So let's do some figuring here, okay? If x is a cosine function, then the velocity will be a negative sine function. But x is not a cosine function. X is a negative cosine function, right? Okay, so if x is a negative cosine function, then v must be a positive sine function. Okay, so let's figure that out. Okay, so this is going to be a positive something times a sine, and then notice that it's omega t, right? Okay, so we're going to go pi times t. So it's got the same periodicity, right? Okay, and then the maximum velocity, this thing is omega x naught, okay? Well, omega is just pi and x naught is 3, so again, our maximum velocity is 3 pi, so we're going to put that in there. Okay, so remember this. We're going to need to remember this for the next part, okay? So this is going to be positive 3 pi sine omega t, omega t, and omega is pi. Okay, now we've got to do a little figuring here. Let's make sure that this is correct, okay? Let's take a look at this graph, okay? This is going to be the slope of that graph. So right off the bat, the slope is 0. Is sine 0? Yes, indeed it is, okay? And then right away after that, the slope becomes more and more positive. Does sine become positive right away? Yeah, it does, right? Sine is this guy, right? Okay, so it becomes positive, it's going to become 0, then it's going to get less positive, right? And and then, right, it's going to become 0, sorry. It's going to become negative, and it looks like that's exactly what we got, okay? So this thing works, right? Okay, and then extra credit, write one for its acceleration. Well, acceleration is just simply the opposite of omega squared times x, okay? This is what x is, okay? So can we do this? This is going to be higher mathematics, right? The acceleration will be the opposite of, and omega squared is pi, so I'm going to put a pi squared. Okay, and then x is negative 3 cos. And we'd have to simplify that a bit, right? The minus signs would go away. The acceleration would be a positive cos function, which makes sense, right? When we're down here in the negative, we're accelerating toward the equilibrium, so we'd be accelerating positively. Okay. Yeah, I think that works. All right.